Today we're going to examine the concept of taking powers of monomials. If I say to you 2x squared y to the third power, based on what we already know, we know that that means I'm multiplying this, because it's in parentheses, by itself 3 times. So that's pretty much the definition of exponents. So that means I have 2x squared y times 2x squared y times 2x squared y. Well, we already know that when we multiply monomials, we are multiplying the coefficients. 2 times 2 times 2 is 8. And we're adding the exponents of the common bases. 2 plus 2 plus 2 is 6. And 1 plus 1 plus 1 is 3. Well, if I look back at these numbers, I can see that really the way I got 8 is to multiply 2 by itself, or raise 2 to the third power, giving me 8, and then I multiply the exponents, because if I have 3 groups of 2, that's like saying 2 plus 2 plus 2 is the same as 2 times 3. 1 plus 1 plus 1 is the same as saying 1 times 3. So, to boil it down, when I'm taking powers of monomials, I am raising the coefficient to the given power, and I'm multiplying each exponent by the power. So, if I look at it and I say negative 3a b to the third to the fourth power, actually let's make that a squared. I am taking negative 3 and raising it to the fourth power. That means a negative number raised to an even exponent gives me a positive number. And 3, so the fourth power is 3 times 3 times 3 times 3, which might seem overwhelming, but it's also 9 times 9, which is 81. So it's positive 81, and what I'm going to do with my exponents is multiply each of them. So a to the 2 times 4 is a to the 8th, and 3 times 4, b to the 3 times 4, is b to the 12th. One thing that can sometimes be confusing is if I have negative x to the third to the fifth power. Well, I know I need to raise my coefficient to the fifth power. My coefficient is negative 1. Remember, 1 to the fifth power is still 1, because it's 1 times 1 times 1 times 1 times 1. Negative 1 to the fifth power, a negative number raised to an odd power, gives me a negative. So it's going to be negative x, or negative 1x, to the 3 times 5, or 15th. Now, one of the things, as I've been saying, is that each of these operations is really simple if you think of it, if you're only worried about one at a time. It does get a little bit more confusing when you have to mix them up. Some of tonight's homework does exactly that. Like it might say 2x squared y to the third squared times, 5x to the third y. So, I've got a problem here. I've got too many things happening. I have this multiplication, but I also have the exponents. So you might want to think about this exponent as saying me, I ran out of room, me first. Because in Gremdas, we do exponents before multiplication. So, I raise 2 to the second power, giving me 4. I multiply each of the exponents by the power, so that becomes x to the fourth, y to the sixth. And now I'm left with a multiplication problem. So hopefully you remember that when I'm multiplying, I multiply my coefficients and I add my exponents of the common bases, x to the seventh, y to the seventh. Honestly, keeping all this straight is enough of a situation that you're going to be having a quiz on a chart that just keeps track of what's happening in each of these situations. So if I think of this as operation, here, let's try that over again. Operation. I need to keep track of what I'm doing with my coefficients and my exponents. So, in the operation of addition or subtraction, I'm just going to call it addition because subtraction is the same as adding the opposite. First of all, I can't add all monomials. The thing you need to keep in mind is that you must have like terms. But assuming I do have like terms, I'm going to add the coefficients and the exponents stay the same. Remember, if I have 2x squared y's plus 3x squared y's, I have 5x squared y's all together. Unlike multiplication, I have to multiply the coefficients and I add the exponents, of course, of just the common bases. Now, if I am raising to a power, I raise the coefficient to the given power, and I multiply the exponents. I do want to make it clear that if there is more than one step in any problem, and we're going to do multiple problems that have more than one step, you're responsible for showing each different step. So if I have 3a squared b to the third power times 2ab, I can't just go to my answer. I have to first show what I get when I take care of that exponent. Who's saying? Me first. 3 to the third power is 27. A to the sixth, because it's 2 times 3. B to the third, and I'm going to take that answer and I multiply by 2ab. Normally in your notebooks we would do the work going down one step at a time, but I'm out of room. 27 times 2, because now I'm multiplying, and when I'm multiplying monomials, I multiply the coefficients. 54, and I add the exponents. A to the seventh, b to the fourth. And that's that.